Welcome to AI Explains. Okay, so I want you to picture a perfectly still pond. You know, you pick up a rock, you throw it in, and you watch those ripples spread out. Now just imagine that pond is the entire universe. And, well, instead of a rock, it's a black hole smashing into another black hole.
That is a perfect analogy. That's pretty much what gravitational waves are. They're not sound waves, that we hear with our ears. They are actual ripples
Yeah.
in the fabric of space itself. When these massive objects crash into each other, they literally stretch and squeeze space like it's a rubber sheet.
And that's what we're digging into today, this ultimate playlist of cosmic splashes. It's from a paper on the GWTC1 catalog put out by the scientists at LIGO and Virgo.
Yeah, exactly. You can think of this catalog as a kind of greatest hits album. It covers their first two big observing runs where they were, actually catching these waves as they washed over Earth.
So let's get into the track list. What did they actually find in this thing?
All right, so they confirmed 11 confident events. And if we're sticking with the music analogy, 10 of these tracks are pure heavy metal. Pairs of black holes just smashing together. But there's one track that's a little different.
Remix?
Sort of, yeah. There's a pair of neutron stars colliding. These are these super, super dense city-sized stars. We can get to them in a bit. But first, the really big news in this paper was 4 brand new black hole mergers.
And one of them was literally huge, right? The heavyweight champion of them.
Yeah. GW170729. That one is the absolute monster of the catalog. It's the most massive event they found, and it happened about 5 billion years ago.
5 billion years. So that ripple has been traveling for a very long time.
A very long time. But my personal favorite is actually a different one, GW170818. I kind of call it the We See You event.
Okay, why is that?
Because 3 different detectors, 2 in the U.S. and 1 over in Italy, all heard it at the same time. Imagine you're playing Marco Polo in a pool with your eyes closed. If you have one ear plugged, it's really hard to tell where the Marco is coming from. But if you have 2 ears, or even better, 3 friends pointing, you know exactly where to go.
So because they had detectors all over the world, they could really triangulate and pinpoint where in the sky that crash happened.
Exactly. They narrowed it down to this tiny patch of sky, which is incredibly hard to do, well, with invisible ripples.
Okay, so let's unpack that listening part. You said they're not microphones. How do you even catch a ripple in space?
You basically use giant rulers made of lasers. That's what the LIGO and Virgo detectors are. They shoot lasers down these long tunnels to measure the distance between mirrors with insane precision. When a gravitational wave passes through, it stretches space, and that distance changes by just a fraction of an atom.
That sounds impossibly sensitive.
It is. It's so sensitive that noise is a huge, huge problem. They pick up everything. The paper actually mentions that the detector in Washington State got its sensitivity messed up by an earthquake in Montana.
Wait, an earthquake 2 states away?
Yep. The ground shook in Montana, and the detector in Washington was basically like, nope, I can't work like this. It just ruined the data for a while.
So if a truck driving by or an earthquake can make noise, how do they possibly hear black holes?
It's all about noise subtraction. It's like, taking an old hissy recording of a song and using a computer to clean it up to take out all that hiss and crackle so you can hear the music.
Got it. And once they scrubbed all that static, they found that one really unique track, the neutron star merger, GW1708 Why is that one the teacher's pet of the group?
Well, for one, it was the closest event and also the loudest signal they got. But the coolest part, black holes are, well, they're black. They're invisible. They don't give off light. But when neutron stars smash together, they create a massive fireball.
So astronomers could actually see it with telescopes.
Yes. For the very first time, because LIGO could tell them exactly where to look, they pointed their telescopes and saw the explosion. It was like watching the movie and hearing the soundtrack at the same time.
That's incredible. So looking at this whole catalog, what's the big picture here?
I think we're building a census of the universe's ghosts. We now know for sure that black holes come in all these different sizes, from about 7 times the mass of our sun to over 80.
But there's a missing page in that census, right? The mass gap, I think they call it.
Exactly. We found the light stuff, like neutron stars, up to about 2.5 times the mass of the sun. And we found the heavy stuff, the black holes, starting around 5 times the mass of the sun. But in between those two, nothing. It's empty.
A cosmic no man's land.
Yeah, and it raises this huge question. Is nature just hiding something from us in that gap? Or do those medium-sized monsters just not exist at all?
Something to wonder about the next time you throw a rock in a pond. Thanks for listening.